Okay, so I want to practice graphs a little bit, and so I decided to come to the Leetcode map, and we're just going to start with graphs, see what we're able to do, and see how far we can get. I reset everything, so now I have a blank slate, so hoping to actually be able to move forward and do a lot of these problems, and I just wanted to kind of wipe this slate clean. So, alright, let's just practice with some graph problems. Alright, so given a 2D grid where 1 represents land and 0 represents water, count and return the number of islands. Okay, an island is formed by connecting adjacent lands, and this is surrounded by water. You may assume water is surrounded on the grid. Okay, so we are going to need a helper function, which will be like def traverse, like this. And then pass for right now, and then what we want to do is we want to say, I tried resetting everything but it still says like solved. Okay, anyways, so what I want to do is I want to now come to, I want to do for row in grid, enumerate grid. So now I have row and index, right? Row and row index, something like that. Then column, index, enumerate row, like this. Now I want to say if so I want to say, I'm trying to count how many islands there are, so I would probably want something which is like a set, right? If row I, column I, not in visited, and row and grid what? I think I can actually simplify this a lot. Grid of row column. Okay. Actually going to go like this. Okay. And now I want to do, so row length is going to be equal to the length of grid, and now column length is going to be equal to length of grid indexed at 0. Now I need to say, like, if not grid, return 0, I think, right? Because there's no grid, so there's no islands, right? Okay. So now for in range of row length, and now in range of column length. Now I don't need this. I can just say row column not in visited, okay, and this one, so if we haven't visited it yet and it's equal to land, then I want to traverse with that row and column. Okay, so now in here I'm going to have row and column. Row, column, okay. So now what do I want to do when I get to one? I want to visit it. So I want to say visited dot add, and then the tuple of row column, like this, okay? Which also means that we need a visited is equal to an empty set, okay? Great, so now what I want to do, I've added it, I want to check myself and say, okay, before I add it, I want my base cases. I want to say, like, if row is less than 0, right? If row is less than 0, then I'm outside the bounds of the array. If it's equal to 0, we're good, okay? So, or if row is greater than row length, okay, and now if, or equal to, right? Because if it's equal to, this is element wise, so if we're equal to, this is also a bad case, okay? Or if hold on, or column is less than 0, or column is greater than column length. If this is the case, we want to return 0, okay? Because we found no islands, okay? Otherwise, I guess the other one, there's one more condition, or grid of row column is equal to 0. If it's water, we didn't find anything. Okay, otherwise now we add it to visited, right? And then now what I want to do is I want to traverse in all 4 directions. So I want to go I was thinking about capturing how many islands, but no, that doesn't make sense. I'm just going to return. So I'm just going to go return here. And now I'm going to say traverse and then row plus 1 column, okay? And then, actually we're going to do this in, like this. 1, 2, 3, 4, like this. Plus 1 Okay, -1, +1, -1. Okay, just like this. And that should add it to our new one, recursively come down, and we're either going to get outside the bounds of the array and stop, or we are going to, I also need to say, like, if I've already visited it, right? So, if, I'm just doing, I could put it up here with more, but I'm just going to do another one. If, row, column, in visited, then we return again. Okay. Otherwise, we add it, and then we traverse. Okay, so now what I want to do is, I found one that is land, and so there's at least one. So result plus equals 1, and result is going to start at 0. So result is equal to 0. Okay. Now return result. Something like this. Let's see what happens. Wrong answer. Why? What's going on? Okay, well, this makes me think that my inner loop never, okay. It's not in visited, okay, is equal to, is there some kind of, so visited is a set which should, I don't think I need to do non-local there, right? Passing these, which have the same name. So does this never get called? Yeah, it never gets called. So this should be okay. All of that should be okay. Print formatted string. Then I want to say row and column. Okay. So I'm coming in here, and I'm getting what I'm expecting. So 0, 1, and 2, and 3, right? 0, 1, 2, 3, yeah. I'm checking if that is not in visited. Okay, and visited is an empty set. And are these strings? Alright, so we are having a problem here. Okay, so we can maybe remove these print statements and just see what's happening. So now, what is it unhappy about? So I should have done the blocking, right? Equal to. And there we go. Okay, awesome. So next, where is the next button? No next. Okay. Number of island. Well, can I just search graphs though? Okay. Here. Here. Okay. Graphs. We're just gonna keep on going. I guess I will. Should we just do them in order? Max area of island, clone graphs, rotting oranges. Okay. I'm going to do it this way so that we have a little bit more. I don't need to click multiple buttons. Okay, so you're given a 2D matrix grid. Each cell has one of three possible values. 0 representing an empty cell, 1 representing... 0 representing an empty... I was doing the things with my fingers, but I was 1 indexing it when it was 0. So 0 representing an empty cell, 1 representing a fresh fruit, 2 representing a rotten fruit. Okay. Every minute, if a fresh fruit is horizontally or vertically adjacent to a rotten fruit, then the fresh fruit also becomes rotten. Okay. Return a minimum number of minutes that must elapse until there are 0 fresh fruits remaining. If the state is impossible, within the grid, return 1. Okay, so we want to do something very similar. I mean, no, we cannot do a depth first search. We have to do a breadth first search here. Yes, because we're interested in time intervals. So each time is going to be a new interval, right? So I am going to, oh, and this gives me a good opportunity to, what was the Python thing for a queue, right? Like, what is the syntax for it? Hold on, I'm going to cheat for a second. Okay. What is the Python syntax for a QUE UE, right? Q and stack. Breadth first search implements a queue, obviously, because it is first in, first out. But we're looking. I also want to ask, like, okay, well, what about a stack? Just so that I can know the syntax, right? For a stack, you simply put it in a standard Python list, and then I can do append and pop. Okay, so pop is for a list. Okay, cool. Q, it's like, yeah, it's this one, the D and then QUE. I just need to kind of remember that. And then I can do append, which is the same as a stack, okay, and then pop left. Okay. So I'm trying to think about how to remember this. Okay. So I'm going to come here, I'm going to say Q is equal to, right, like this, right? Okay. Here we go. So now what I want to do is we're going to come in here and I want to find all of the rotten fruit, right? So for I need to traverse it, okay? So for row in length row, just say row length like this. For column in column length, and now let's define those, and then is equal to length of grid, right? And then this one is going to be equal to length of grid, just the first one. If not grid, return what? In the case that there's until there are 0 fresh fruits. Okay, so that means time interval was 0. Okay, so now I have this, and I want to add everything to my queue. So if grid of row column, okay, is equal to a rotten one, which is 2. Now hold up, is this an actual 2 or is it a character 2? 3 possible values. Does it? Okay, so these are actual numbers. All right. So if it's equal to 2, then I want to q.append row column, right? I think so. Okay. And I want to keep doing that so I get all of those into my stack. Okay. So now what I want to do is I want to go time interval by time interval. And I want to find all of my rotten fruit. So I want to go through each of my rotten fruit for each time interval. So while queue, I want to now have a temporary queue. Okay. Time plus equals 1 temp queue is equal to a new queue. Okay. Time is going to be equal to 0, the 0th, right? Because it's the first, we come here at, that's at like day 0 is how many bananas there are already. And then I come here and that's a 1 time interval. So yeah, it should be a 1. Okay. So now I come here, and what I want to do is I want to traverse my entire queue. So I'm going to come in here and do the same thing. So while queue, like original queue, I am going to continue to, I'm going to go through all of the items. So I'm going to say new, is that a keyword? Doesn't look like a keyword in Python. Okay. I was like, wait, hold on, I can't use that. Wait, new is not a keyword in Python? How? Okay, anyways, that's fine. It's fine. Okay, so what do I want to do with this? I want to... I want to create a new... So just like current, I'm going to call it current node. okay? It's going to be equal to q dot, what was it, pop left, like this. So is it capitalizations? Hold up. No pop, okay, cool. Pop left, right? So I took it out of the original queue, but I'm not going to put into this temporary queue, or I'm not going to put all of the adjacent ones into my Do I need a visited array? Do I need a visited array, or can I use the number itself as visited? Because the only time that something could be unvisited is if it's a 1, right? And every time I visit it, it's actually going to change it to be a 2. So I can use that in itself as a visited array, or a visited like marker. So I don't think anyone. So I can maybe say if so I'm trying to add to my temporary queue now. So if current node so this is going to be a tuple, right? Can I do I don't like this. I don't like this because it's unclear. So what I want to do is I want to come here and I want to say row current and column current. Okay, I don't know if that's any better, but so if row current is less than 0, well, I want to do when I'm adding it is greater than or equal to 0, right? And row is less greater than or equal to 0 is less than this row length, and column is greater than or equal to 0. I think I'm going to condense these a little bit. Okay. And is smaller than column length, and grid of row is equal to this 1, right? A fresh fruit. In this case, I want to temp q dot append, and I append the and. Okay. So only in the case where I'm inside the array and that array is a fresh fruit, which means I, number one, have not visited it, okay? Then I want to append it, all right, to my queue. Now what do I want to do? I want to keep doing that for each one of my current rows. So I will come here, I'll come here, right? I visited both. Now I have 2 in my queue, so the next time this one will come here, and then this one will not go there because it's already visited. But once this interrupts, I want to do queue equals temp queue, right? And hopefully this does it by ref, or hopefully this does just a shallow copy, right? Or wait, hold on. Do I want shallow copy, or I forget what the terminology means. I should make sure that I'm clarified about that terminology, but essentially I don't want it to point to the same object. I just want all of the elements in my temp to go into my queue right there. But after that, once we get all this, I should be able to return just the time. How many intervals? I don't know. Let's see if it works. No, is not a range. Where are we? Right. Okay, and this one like this. Whoops. Okay. Let's see. Internal error. Oh, because I don't have internet. Okay. Well, I still don't have internet. Okay. Come on. Come on. Oh my goodness. Well, I guess we just look at it a little bit more and see what we can do. Okay, so let's come back over this. Points of... Okay, now I have internet. Points of, like, this one might be wrong, right? What am I getting? Expected for... Okay. So is it... coming in here and going through all of them in one round? Because I'm only doing one pop left. No, I'm coming back up, but I'm popping left from that same queue, right? So it's definitely coming in here and hitting this, and then it's the same condition there, so it should. And then I'm getting this, and then if maybe this doesn't, hold on, maybe there's some logic here. So if my row is greater than 0, okay, and my row is less than the max, yeah, if columns are greater than or equal to 0, yeah, and column length is smaller than that, that makes sense to me, and if right, I need to check all of my this is just saying my current one, which I just added a rotten one. So of course it's not going to be. So, okay. I see the problem. Okay, so what I want to do is, for row neighbor, column neighbor. Oh, this is terrible. In how can I do this? One. I need to close my window. Left. So I want to add this to those. But there's two that we need to do. I know that there's just like there's some trick that you're able to write it such that it is able to just, you're able to do this in one line of code that you add. Oh, you create a new variable. Maybe I do say current node. Current node, right? Is, hold up a second. Am I able to pause? Hold on. I'm gonna go close my window. Alright. It worked. I think we're back. That's cool. On my Mac, I'm not able to do that. Okay, so I'm gonna go and ask for that little trick. Let's see. I want to iterate over all four of the coordinates. Up, down, left, right. Just tell me how to do that. Not the rest of the code. Okay. Okay, here we go. Okay, so dr for like in calculus, right? So delta t, delta c in, and then our range, and then we have our tuples. Okay. So that's all I wanted to know. So I have a range, and then I have this, I have tuple up, down, left, right, this, and then I could do like -1, 0, 1, 0, 0, and -1, and then 0 and +1. So like this, and then I will have dr, not dt, dc. Okay, and then this one I will still have that, whatever, rc and cc. Okay, so now I want to do this, like, plus dr plus dr, okay, and plus dc plus dc, right? Then come in here and say plus dc plus dr, like this, okay, plus dc plus dr. Okay. Does this look right? Let's see. No. No. Well, fine. Okay. Right. If we can get the syntax correct, then we'll see if our algorithm is correct. And this is not correct either. Wait, no, yeah, it is. Okay. Yeah. Okay. So, infinite loop. Is equal to 0. Now, so, okay, we're getting an infinite loop here. I think maybe I crack this open and start thinking about it. Okay. So I am coming here and I am going to add this one and add this one, right? That's what I'm trying to do. So if here it's good, it's good, it's good, it's good. It is this one, right? I'm going to come here, append it, and then I also need to change it. So I need to mark it as visited. So grid of RC plus DC, okay, and CC plus DC, DR, oh my gosh, okay, is equal to 2. It's a rotten one. Okay. Well, we did not. Getting an off by 1, so. In the case that there is one banana, okay, so in the case that there's one banana, we want one rotten banana, but let's say that there's no other bananas, it's just one rotten banana. I want it to, it is going to come in here. Yeah, that makes sense, because there's a rotten banana. It's going to increment it. What did this one fail for? Expected. Oh, right. I forgot to say, like, we need to check. We need to loop through this one more time. So for, I'm just going to copy and paste this. Here, right? So if we do find a rotten banana, if we find a good banana, we need to return -1. So if there's still any good bananas left, that means we couldn't find one. We return the -1. Okay, but this still does not help our timing thing. So now, when would the timing be accurate? Because I could increase it by 1, but I don't feel like that's the correct thing to do, because if I have 1 here, right, if there's 1 banana and it's rotten and there's no other bananas in there, well then my time frame was 0. Oh wait, sorry, I was thinking, like, if I put -1 there, I come here, this is incremented to 1, okay, and that's running here, and then I go up to the next one. I think that makes sense. Okay. Let's see if it takes it. No, it does not. So... Okay. There we go. This one is warheads. So, watermelon warheads. Let's see how it smells good. Tastes good too. Okay. So, what do I want to do? I want to come in here and I want to try to get what was it even saying? For the case where there are no bananas. There's no bananas, right? Now I just feel like I'm adding a whole bunch of if not Q, return 0, right? I just feel like I'm adding a whole bunch of things here. Again, wrong answer. Okay, what is this now? Well, there should not have been a Q, right? Your output is 0. Oh, come on. Oh, come on. Okay, I see the problem. I'm running around in circles right now. Okay. All right. Causes your code to return for specific edge cases, exactly. All clear bugs. Our first loop finds rotten oranges and puts them in queue while queue loop runs. Time becomes 0 initially since there are no fresh. But what if... Alright, the fix. The most robust way to handle this is to count fresh oranges from the start. Okay. And then do this. Okay. This is the case. Fresh flag is equal to 1. It's equal to 0. I don't like doing it this way. This feels wrong. If not fresh flag, okay, return zero. Right? Is that correct? At this point, I'm just like, okay. I don't know. We'll see if this passes. Okay, this one was accepted, but I kind of want to say, like, I need to come back to this one. So I can come to this one. I refresh it, right? And I'm going to... Oh, come on. Come here. I'm actually just going to go like that. And then star this one. Like, I need to redo this one. Maybe I do that, but star it. Okay, I haven't. Anyways, course schedule number 1. Okay, let's try this one. Okay, you are given an array prerequisites where prerequisites of I indicate that you must take course B first if you want to take course A. The pair 0, 1 indicates that must take 1 before course 0, okay? There are a total of num courses that you are required to take labeled from 0 to num courses of I. Return true if it's possible to finish all courses, otherwise false. Okay. True, first you take course 0, no prerequisites, and then, or to course 1, and then take course 0. You must take course... Okay. So for this, for course 0, I need to okay, you're given an array prerequisites where prerequisite of I is equal to AB indicates that you must take course B first if you want to take course A, okay? The pair 0, 1 indicates that you must take course 1 before taking course 0. There are a total of num courses labeled from 0 to num courses. Return true if it's possible to finish all courses, otherwise return false. But this one seems very similar to the thing that I was failing at here on HackerRank, right? Okay. So this one was like something about cycles and looking for a cycle, I think. Now, how can I think of these prerequisites as cycles? Is it an adjacent? It would be a directed graph, right? And I can think of those as edges and see if any of my edges come back to each other. Something like that. So how would I do this? Okay, so my so Q is equal to this, and I'm gonna say so these are just the number of edges, right? If not prerequisites, I can return true. Okay. Otherwise, I can add the first prerequisite. Man, I don't know about this one, actually. Okay, so I'm going to go to the solution. I'm going to see, and what I'm trying, yeah, so, okay, so it is cycle detection, yes. And what I want to find out is, okay, I think that actually this question is very similar to this question. This one is, like, HackerRank, the resources are, like, almost non-existent. So it's actually really nice that we found one that's similar on Leetcode because they have a bunch more resources. So let's see what we can get from it. Each course is a node, and each prerequisite is a directed edge. Yeah, that makes sense. You can finish all courses only if there are no cycles in this graph. Yep. A cycle means course A needs B, B needs C, C needs A. You're stuck forever, okay? So something that I'm realizing is that these cycle detections are able to analyze dependencies of one thing to another. Okay, so if I'm reading a question and I see something that's talking about something depends on something else, the other thing depends on something else, this has dependencies on other things, I should possibly consider this like cycle detector. Okay, we use depth first search with cycle detection. While doing depth first search, keep track of courses in the current recursion path. Okay, if we visit a course already in the current path, cycle found. Yeah, that makes sense. I'm trying to figure out how to do the depth first search based off of the, was that an adjacency list or a edge list, right? Okay, so that is a concept that I need to make sure that I reinforce within myself. That's not an adjacency list. That's like a edge list. Well, then how do I need to create a adjacency list from that? Is that what they did? I think so. Yeah. Okay, so let me come back to this question and stop looking at it, right? And now what I want to do is I want to, okay, so first thing is create an adjacency list, okay? So it's going to be a dictionary. Adjacency list is equal to default dict, and we have a key of int, right? And what am I going to actually have? What's the key value? The key is going to be the node itself, node, and the value is going to be the edge to the neighbor, right? Kind of like that. Okay, so now for item in prerequisites, let me just copy and paste this. In prerequisites, I'm going to get a list. So each one, I'm going to get 2 elements. Okay. So now I can do adjacency list indexed at item of 0, the key, is equal to item of 1. Okay. I keep doing that. Now I have access to this adjacency list. I want to be able to see if there's a cycle. So I'm going to do a visited. Okay, so for I. Okay, so I want to create a list. Visited is equal to a list which contains 0 for blank in range of num courses. Okay, kind of like that. Awesome. So we have this visited here. Okay. And now I want to traverse this, right? I'm going to try to go and do a depth first search. Okay. Actually, I did need the def there anyways. Okay, on something, I don't really know what we're doing yet. And I want to say, like, hey, have I visited you yet? If current in if visited at current, so current is the index, right? And that's going to be the class. Okay. Because class 0, okay, right here, and intake course 0. Is this... indicates you must take course B. From A, I need this. Okay. If visited here, return false, something like that. Otherwise, current is not, and current is going to be, current is there, current, and then visited at current is equal to 1. Okay, and now, so I processed myself, now I need to recursively go in. So for edge in but if I have one node that has a whole bunch of edges, this is wrong. I want it to be something like append and then time indexed at 1. I don't think that this is right, but for edge in adjacency list, okay. For edge in adjacency list, I want to depth first search, yes, on that edge, right? And then on prerequisite of 0. but I want to say if not, return true. You can, okay, and then return true here. I think that this is wrong, but that's why we're going to use okay, yeah, so I need a lot of help on this one. So we're going to come here and ask it, tell me which concepts I am struggling with on this problem. Okay, cool. Your current code shows you understand the basics of depth first search, but you are struggling with 3 core concepts: graph representation, state management, and depth first search pattern. Okay. You initialize adjacency list as a default dict, but an adjacency list must store a list of neighbors to each node. The error: default dict sets the default value to 0. Okay, you cannot append to an integer. So I obviously am struggling with, I need to go and review like default dictionaries. Okay, of a list. Okay, so the value that I put in here is actually what the value is. Okay. State management, the 3-color problem. In cycle detection, a simple visited array isn't enough. You need to distinguish between nodes we've never seen, nodes currently in our recursion stack. If we hit one of these again, we found a cycle. Nodes we've completely finished processing. Okay. The 3-color problem. In your current code, you mark a node as visited and then never unmark it or distinguish it from a finished node. This will cause a false positive even for valid paths. Okay, so this is good. We're coming into things that I didn't know about. So, okay, great. We found a new concept that I'm confused, but confused means you're learning. The search pattern. You have a few syntax logic. Okay, so for iterates over every key in the dictionary, not the neighbors of your current course. It should be for, okay, the starting point. You only call depth first search once if the graph is disconnected. Alright, disconnected graphs. Okay, oh, there's a lot going on in this problem. Okay. So, build the graph correctly. Is a list, so the values are lists, okay? In prerequisites, and I'm extracting the course and the prerequisite here. The course is going to be the key, the prerequisite is going to be the value, okay? Use a set or array to track the current path. Recursion stack, and another to track nodes that we know are safe, fully processed. Visiting and visited, okay? But in the other depth first search problems that I saw, we only had 1 visited. So now I've never seen 2 visited. What is special about this problem that requires 2 visited? It seems like it's this right here. Has cycle. If current already checked this node. Okay. Backtrack, remove from current path. Okay, so the backtracking, right? Okay, I kind of remember backtracking. Okay, yeah, this problem, I'm gonna have to go in and I'm gonna look at this one again. This is a very good one. I want to star it. Okay. So what do we think? Maybe we do this one right here. Okay. You're given an M by N 2D grid initialized with these three possible values: a -1, a water cell that cannot be traversed, 0, a treasure chest, infinite, a land cell that can be traversed. We use integer to represent infinite, okay? Fill each land cell, okay, with the distance to the nearest treasure chest, okay? If a land cell cannot reach a treasure chest, then the value should remain infinite. Assume the grid can only be traversed up to, okay, so this one right here, I just find a treasure chest and then do a breadth first or depth first search, it doesn't matter, recursion back through each of the items. Like if I find land, I go and I change this one. Okay, so what I'm thinking is I have okay, depth first search like this, and now I have my row and column, okay? And now what I'm going to do is for I in range length of grid, for j in range length of grid indexed at 0, like this, okay? If not, grid return, what do we want to return? I don't know. Modify the grid in place. Okay, great. So we just return. Okay. So now what I want to do is I want to come in here and I want to say if grid indexed at ij is equal to is greater than 0, is greater than 0, then what I can do is I can come in here and I can, no, if it's equal to 0, if it's equal to 0, then it is a treasure chest. Okay, so now I want to do a depth first search on this with I, j, and now zero, and I want 0 to represent like the distance here. So I should have like distance. Okay. So now I want to be able to say something like if row is smaller than 0, or row is larger than or equal to should have just captured those. Row is equal to length of grid equal to length of grid indexed at 0. Then I move this up. Okay. Like this. So if we have this one, length of row or column is less than 0 or column is greater than or equal to length of column, return, we just return, right? Because we're doing everything in place. So now I want to say if grid, so -1 is water, of row column is equal to -1, then we return as well. Okay, so now I want to check if we're equal to 0. If we are equal to 0, I want my distance to be equal to 0. Okay? So now what I want to do is I want to traverse up, down, left, right. Okay. Okay. So for differential row, differential column in this one in tuples. So 1, 0, should have done this. 2, 1, 2, 3, 4, okay. -1, 0, 0, 1, 0, -1. Okay. So in this, I want to depth first search on row plus dr, okay, column plus dc, distance plus 1. Okay. But I want to modify in place. I want to say grid of row column is equal to distance, right? Do this, I do this, and then I come out. Is it right? I don't know. No. Wait, what? Oh, is equal to, if we're on a treasure chest, we're at 0, right? So let's see. This got the wrong answer. Well, it's a typo question. Where did I do column? Huh? it is. Alright, we're gonna do this. Okay. Alright, we got another one. So okay, we got a thing of so one of the things that I'm trying to do is, if I have a visited array, okay, let's think about this case, right? Let's say that I have here, I go down, I say this is a distance of 1, and then this one is a distance of 2 right here, okay? And I visit all of them from it. Well, let's actually let's okay, then I visit let's say that this one is land right here. I know it's a -1, but I'm trying to showcase something. Let's say that this one, it came to 0, it said, okay, great, here's treasure chest, distance +1, distance +1, distance +1, so now we're at like distance of 3, okay? But then notice this one, I can't do another visited right there. Like, I can't add it to visited. Maybe I need to create a new visited for each one. Okay, so visited is equal to set, like this, a new set. Do I have access to it from my helper function? We'll see. And then I can do here if, and then row column in visited return. Okay. Otherwise, visited dot add, right? Because add to a set, and I want to do row column, something like that. Let's see. Ew. Okay. Visited is not defined. Did I misspell something? Okay. Here's my definition. Okay. Looks like you are there and you are there. Okay. Wrong answer. Okay. Well, at least we got a wrong answer. So now let's come here and do the exact same thing here, and then I'm probably going to end the video once we understand, like, look at this one, and then on my own time kind of go through kind of what I recognized with this. Huh? Is it the same one? Wait, where am I? Islands and treasure? Is this the same as the rotten banana one? Hold on. Okay. It's almost, oh no, it says it's almost identical to the rotting oranges. Okay. Problem you just solved. Rot spreads, okay. So depth first search I should have been using. Okay, but for finding shortest path in grid, depth first search has many major flaws. Okay, so that was my big problem. Alright, so yeah, I should have done breadth first search for shortest path in unweighted grids. It radiates outwards. Okay. the multiple source efficiency. The error. Your code calls DFS every time it finds a 0 within treasures. Oh, and I would have had to update my max, right? Or like min. Okay. You should put all your treasures into a queue at once. This lets the distances compete and fill. Okay. Breadth first search. Is it possible to do it with a depth first search? Would you like a union find problem next? No. Guaranteed shortest path. Okay, so we would need to do it with a breadth first search because we're trying to find the shortest path. Okay. Alright, I think I'm going to leave the video off here. I'm going to go and try to understand this one more. And I just wanted to, I was studying today graphs, if I can talk. I was studying like graph problems, and I wanted to get some practice in and actually do some graphs and find out where did I get stuck, what were some of the concepts that, you know, maybe I understood it when I'm watching a video, but it's very different when you're doing it live and you're trying to solve a problem that you either have never seen before or have seen a long time ago or whatever, right? Like whenever you're doing it yourself, you're going to come into like different things that you didn't expect. So I feel happy that we were able to uncover some pretty cool new concepts that I was unfamiliar with. I need to go and represent or figure out graph, like how to do adjacency lists a little bit more. I need to figure out what this 3-color problem is. I need to figure out why this one uses 2 visited arrays. That's a weird thing. That's a very weird thing. And then search pattern iterates over every keyword in the dictionary, not the neighbors. So I like this question. I really like this question. Although I am considering, should I go and do a little bit of arrays? How are we feeling about that? Do I want to do like? Let's just do it. Okay, contains duplicates, because the other thing that I'm trying to do is I'm trying to like, I realized that I had some problems with my arrays, or maybe I'll make this a different video. Yeah, I'll probably make it a different video. Okay, awesome. So I will leave the video off here. Thank you guys for watching this video. If you liked it, subscribe. I would love to have you around. And yeah, thanks for joining me on this journey. My name is Timothy Lee Grant, and I'll see you guys in the next video.